So here's the same problem that we did the other day. I got my new pad, so I'm going to try and make this really short video for you. All right. It says, name and provide the chemical formula of the triprotic acid that forms with hydrogen ions in the presence of arsenate ions. Okay, so there's a couple of things going on here, guys, that we need to make sure that we're getting. Okay, and those two things are that we're forming an ionic compound, all right, and we're naming an acid or a base. Now, let's start with number one. Number one is forming an ionic compound. So this is review from last year. Okay, so remember, when we're forming an ionic compound, we have to look at the charges, right? So these are the elements that we're forming into a compound, right? Hydrogen, and the other one is actually another compound called a polyatomic ion called arsenate. All right, I'm gonna make sure to put this list of compounds into your notebooks. All right, then we got to establish the charges. Okay, well, I know that hydrogen is a +1 ion, all right, or cation, and I know that arsenate is a 3- ion. Now, I know this just because I know it, but I'm going to give you guys a reference document so you guys can look these up. But these charges, you just got to know. And we're going to get to why they're this later on in the class, but for right now, just know that these are the charges that carry. Now, of course, now, what we're going to do then is, in order for us to get these compounds correct, right, we're going to do the old trick that we used to do, and that's to do the fish, right? So this guy, if you just switch over the charges each become the subscript of the other guy. And if you kind of look, it kind of looks like a fish. That's why I call it the fish. So if you switch over the charges, then your compound becomes hydrogen 3ASO4. Okay, that's the compound. Now, I know some of you are asking, well, why does that work, mister? You have to remember that a compound has to be electrostatically neutral. That means that the charges have to cancel out. So if I was to look at the charge of hydrogen, right, hydrogen is a 1+. And if I was to carry the charge of arsenate, right, that would be a -3. So basically what we have here is we have 1 minus 3 is equal to, in this case, they have to equal 0. Now, the way we have it right now, right, 1 minus 3 does not equal 0, right? 1 minus 3 does not equal 0. So we need to make sure that these two charges are able to cancel each other out. So what do? Well, we multiply this guy by 3. 3 times 1 minus 3 now equals 0. And if you look at these numbers, right, these are what we use to cancel out the charges. So in this case, we had to multiply, right? In this case, we multiplied by 3. And in this case, we multiplied by a -1. Now, obviously, you don't have to write that, but those numbers are the ones that become the subscripts. All right? So when you rewrite the compound, it becomes H3ASO4, right? That's why the fish works. Basically, it's an easy way to get the compound to the correct balance. Now, remember that it has to be the simplest whole number ratio. So like, for example, if this was both like a 3 and a 3 over here, then they would both become 1, right? You have to reduce, okay? So why is it called triprotic? What does triprotic mean? Okay, so looking at the word triprotic, okay, basically what that means is you have 3 protons. 3 protons. Triprotic means 3 protons. Let's see if I can move this. There we go. Triprotic means you have 3 protons. Now, hydrogen has a proton. That's why it carries a +1 charge, right? It's just a single proton. So when we're talking about the word triprotic, what we're saying is that there are 3 protons present in this acid. So this number here of hydrogens is what we know as triprotic. Now, if there would have been 2 hydrogens, then we would have called that diprotic. And then if it was 1 hydrogen, it would be monoprotic. Okay? Now, to name it, right, there's two polyatomic ions that deal with arsenic. The first one is arsenate. Okay, and I want you to pay special attention to that. And the other one is called arsenite, which is ASO3. Now, both of these guys carry a -3 charge, so that doesn't change. Okay, they both carry a -3 charge, but their names are different because what dictates their name is the number of oxygens. Okay, so I want you to pay special attention to this guy also. Okay, so remember, they both carry a -3, right? They both carry arsenic, and they both carry oxygen. What's different, okay, and I want you to pay attention to that, is the number of oxygens. The one with the most oxygens is going to carry the ATE ending. The one with the least oxygens is going to carry the ITE ending. Based on that, okay, oh my goodness.
Teachers, hello, good morning. Just to remind you that today we're celebrating Mr. D. Anthony Lopez Waste for winning Secondary Teacher of the Year. So come by, for the state of Texas, sorry. So come by to the cafeteria from 11:30 a.m. to 12:15 p.m. Pick up your to-go lunch that will be served in his honor.
I'm making a video.
Don't carry him down here, just come over and get your lunch and go. Thank you guys, enjoy, bye-bye.
As I was saying, depending on the number of oxygens is going to dictate whether it's called arsenate or arsenite. Okay? When you're naming the acid, that's going to dictate whether the acid is called arsenic, sorry. Or arsenis. Okay? Remember, an acid is anything that releases hydrogen ions. So because this guy has hydrogen, it's now formed an acid. Now what we need to determine is this going to be called arsenic acid or arsenis acid? In this case, because we're working with the ASSO4, right? The ASO4 instead of the ASO3, this guy is going to be called arsenic acid. Okay.